In this demonstration, I'm going to show you how to look at a chart or graph and identify where specific z-scores might be located when they're given to you. I'm also going to show you how to identify which z-scores might be considered unusual when they're not already located on that graph. A few key points that you want to remember when you're trying to determine the answers to a problem like this or interpreting a problem like this are what is considered unusual and how are z-scores placed on a number line. Well, z-scores are always located in the same specific order. When you have a normal distribution, you have a line and you have your normal chart. In the center is always the mean. And when things are normalized, the mean is always 0. And along the bottom here, you have essentially a basic number line. And your z-scores go at 1, 2, out to 3 standard deviations. And on the left-hand side, you have -1, -2, and -3 standard deviations. Then you have your breakdown of your percentages of data according to the empirical rule. And here, at 1 standard deviation, you may recall you have approximately 68% of the data. When you get out to here, 2 standard deviations, you have approximately 95% of the data encompassed. Now, when you fall out beyond that 95% of the data range, out here in this area, out here, once you fall out beyond here, we're talking about unusual data. So if you're out here, then if you're beyond these 2 standard deviations here, you're talking about an unusual event. So anything that goes out beyond here is an unusual event. So that's how you can determine that. So this is how your z-scores will always lie. So these are considered your z-scores, and they always go in this type of order. Your positives are on your right of your mean, your negatives are on your left. So it's just like a regular number line. So you've got 1, 2, 3 on the right, -1, -2, -3 on the left, and unusual values fall out beyond the 95% of data or beyond 2 standard deviations. So let's see how this would look on one of your homework problems. Alright, so here's a problem that looks like one you might have on your homework during week 1. The midpoints A, B, and C are marked on the histogram and match them to the indicated scores, and which score, if any, would be considered unusual. Well, you notice that that histogram looks an awful lot like the normal curve that we drew previously. Notice that it starts low, rises up, and gets low again. And you have the midpoints A, B, and C. The Z's match 0, 1.46, and -2.09, and we just need to match those to A, B, and C. So as we discussed, we said where our z's fell, and they always fall in the same spots. In the center, a z of 0 will always be in the center. So z of 0 would be B, because 0 is always in the center. On the right-hand side are positive z-scores. We never have negative zeros or z-scores on the right. So C would be our positive z-score of 1.46. And I know that because it's positive, so that's going to be our C. And on our left is going to be our negative z-score of -2.09. And I know it's that one because it's negative. So that is our A. And that's how I would answer that question. Now, which score would be considered unusual? Recall that the criteria for a z-score to be considered unusual would be that it would need to be beyond the range of 2. So the only value here that it is beyond the range of 2 is this one. This one is greater than -2, or smaller than -2 in this case. It goes beyond 2 standard deviations in the negative direction, so negative 2.09 would be considered unusual. So that's how you would answer a question such as this one on your homework.